Okay, so here we are with our Space Invaders game. So we are building this for the Arduino, and we created a spaceship graphic, and we have now made a spaceship game object. We built this game object class that we're going to use to basically control like our game objects, to move them around, to draw them, and then we built the alien ship. And then we had a whole bunch of aliens, and so actually I had deleted some stuff here, but it got closed out. So anyway, we had some extra game objects here of us, like a single alien. We don't need any more, because now we have an array of aliens in our alien fleet. And then here we something's wrong here. Let's see. I'm losing it. There we go. And then yeah, I'd set the speed, so I removed those aliens there as well. And then here's where we initialize our alien fleet and set the speeds. We set the speeds of the spaceship. And then here we have move and draw functions for our alien fleet. Okay. And so the next thing that we're going to do, and I'll show you here what it looks like. So here we have our alien fleet kind of working its way down the screen. There is something we need to fix. So doing some debugging on this. And what we realized was that with the move horizontally function, we don't actually need to check to see if the new position is less than 0. What happens if we do this right here is that if it gets to, basically if you end up going to a negative position, it resets it to 0, and so it gets like shifted sideways, the one on the end, and it's a little bit of a bug. So we're gonna get rid of this, and what that's gonna allow is for the aliens to go off the screen, and then we're still gonna turn it around here, and we're gonna change this to be less than or equal to 0 instead of equal to 0. Okay, so for less than or equal to 0, and then here we're going to actually, we'll just get rid of this, right? We'll just do this. So we're going to take the new value regardless, and if it works, we're going to basically, we're going to turn true or false if we're going off the screen. And so this is not going to bound it on the screen anymore, but what it will do is tell us if we're going off the screen, and that solves that bug, sort of. Now it allows it to go off the screen, but it will prevent a situation where we're losing, basically getting like, if we had a weird combination of speeds, then we would end up with them getting shifted to the side. And so what can happen now is that our aliens could end up going slightly off the screen, but it should still work fine. So like if I were to set this speed here, the horizontal speed, to let's set this to be 3. And so we're starting at a position of 4. And so now we'll see that left one go off the screen a little bit, I think. It'll take a long time to play. Yeah, right. So we see it going off the screen a little bit. But I think that's okay. So anyway, that done. The next thing we're going to do is we're going to kind of make some game loops that we're going to use to track all this stuff. And so coming back to our main function, we're going to go to our below our loop here. And we're going to say void sound loop, and we're not going to touch this right now, but we're going to have it. I'm going to say void move loop, and we're going to say void render loop. Okay, and so these are basically the kind of the 3 things we're going to have going on. And so I'm going to put function prototypes for these up at the top so that we can use them when we're ready. So we got our sound loop, got our move loop, and this. And then to correspond to this, and just to note that you might be starting to get to the point where you're running out of memory. So one of the, so these things live in the flash, but things that are inside of the functions are going to live in the RAM. Specifically, when we initialize our display, it's going to allocate some RAM for it. And so if you get to the point where you're running out of memory, what you're going to find out is that you won't be able to allocate this display. So make sure you got this serial print statement. And so if it doesn't allocate the display, the program won't run, and it'll tell you on the that it failed. So anyway, come back to here. We're going to also use now our millis timer class here, and we're going to initialize some timers. And so we're going to say millis timer alien move timer, and we'll set that to be the frequency that we want these guys to move at. So we're going to start that at maybe like 200, and we'll see if that works, and if we need to make it different. Millis timer, this will be spaceship timer, move timer, and we'll set that to be maybe move the spaceship every 100. I don't know. We'll mess with that one, and then we'll say millis timer display update timer, and we'll set that to be, so let's say we want a refresh rate for the display of like 30 frames per second. Would be 1000 over 30, and so that's about 33. Okay, so we could do something else. You could change that, but so we're going to start with this one here, and let's go down to our render loop, and we're going to say if display timer dot time up display update timer dot reset, and that's all we got to do. And now we can update our display here. And so if we look at here, basically what it does is we reset it, and what the reset function does is it just sets the current start time to be the current time, and we can update the delay if we want. And time up is just going to tell us if a certain amount of time has passed. And so in this case, we set our wait time to be for the spaceship, or for the render loop, we set to be 33. So what that is going to do is every 33 milliseconds, we're going to see that this time up is going to come back as true, and then we'll reset the timer and we'll perform our tasks. And so now we're going to put all of our draw functions in here, just like that. And now it's going to take care of rendering that for us. And so now we just need to put this, our render loop, at the bottom. All right, and then we'll call, if we made an update, we're going to call this right here to update the display. Okay, and there we go. We've got a render loop. We got our move alien fleet loop. Okay, and then let's actually now get our move loop going. And so in there, we're going to use our alien move timer. So if dot time up, and then we're going to say, and just a note, so this is on the link to the GitHub link that I shared, and so if you need to go back and copy this in, you can still go back and copy this in. If you're missing any of this stuff, you can go back to the previous lessons to get that other stuff that you're missing. And so if it's the time's up, we're going to say alien move timer dot reset to reset that timer, and then we're going to move the alien fleet. Okay, and now we've got our render loop. We're going to put our move loop, should come first. Okay, and then let's put this in our render loop as well. So in our render loop, render the game objects on the display. Okay, so every X milliseconds, we're going to clear the display. Then we're going to draw game objects, and then we're going to show game objects on display. Okay, so we got our move loop, and we are moving the alien fleet, and then we're going to do this as well with the spaceship. So if spaceship move timer dot time up, and then we're going to just do I don't think we have anything for the spaceship right now, so let's make a move function for the spaceship. So we're going to say void move spaceship. Okay, and let's go ahead, and here we're going to call that, we'll say spaceship move timer dot reset, and then we're going to move our spaceship. And now let's make a move function for the spaceship. And so then we have our spaceship dot move horizontally. And if you want to add in vertical movements here, you can as well, but we're not going to do that. Okay, so we comment that out because we have to add directions and stuff for it. So with all this, we've taken a lot of the work out of our loop here. I'll get rid of these right here and put it into these different loops. And I'm going to add the sound loop here too, and we'll do this at the end, so it doesn't do anything. And so I'm going to reduce this delay to about maybe like 3 milliseconds. I'm not sure. Maybe I'll just make it be 1. Okay, and so if we verify this, let's make sure everything compiles correctly. Looks like we do have a warning somewhere. Okay, so we have an unused variable. Okay, and so here it looks like we're using about 40% of the RAM. And so look, we only have 2048 bytes, and we used 830. And so let me actually double check on the board here that this is going to work. Okay, so I just tried this on my Arduino here, and it runs for a couple of loops, and then it stops. And so probably what's happening here, let's try this actually on the simulator and see if it works for us. And so here we see that's working as expected, right? If I run it on my board itself, though, it crashes after a couple loops, and I think what's happening is that we're running out of memory. And so maybe this I don't know if this simulation tracks the memory usage, but it comes down to this. So with when we uploaded it here, we saw that we're using 830 bytes of RAM, and we have 2048. And so if we subtract out the 830 minus, or 2048 minus 830, what we're going to end up with is, let's see, 2048 minus 830 is 1,218 bytes of RAM left. And so this is how much memory we have. And then when we allocate our display object right here, this is going to, let's come to here, it's going to allocate this much. So the width was 128. times the height plus 7, so 64 plus, let's just grab this calculation. And so in our context here, where did I put my calculation here? Okay, so if we look here, we have, let's see, so our width was 128. We're multiplying that by our height plus 7. That's going to be 64 plus 7. And then we're going to divide all this by 8. And so 64 plus 7 is 71 times 128 is then divided by 8. And that is 1,136. Okay, so if we subtract away 1136, we're left with, let's see, 2,048 minus 830 minus 1136. And we're left with 82 bytes of RAM, which we need to call our functions for the stack. And so we're probably ending up with a stack overflow, is what my guess is, at some point in, and that's why it's crashing. And so the next step here is we have to make a choice whether we want to continue with this board and see if we can make this work and reduce some of our RAM, or if we want to move to a different board that has a little bit more RAM that we can work with, so we don't end up in a situation where we're running out of memory. Okay, so there's a couple things we could try. First of all, these buffers here take up space, right? This is 1, 2, 3, 4, 5, 6, 7, 8 bytes, while this is 16 bytes. And so we can try putting these in program memory. Okay. I don't know if this is going to work, but we can try it and see if that solves it. And so if we validate this, we can see if that changes. Oh, doesn't like that. Must be const. Okay. Const. So we have to set these as constants so that it knows they won't change. And I don't know if we need to do something to access those now. That's different. Okay, that worked. And let's see how much it changed our. Oh, no, it didn't work. It says success though. Interesting. Okay, so now to make this work, we need to come back to our game object and do const there and const there. Okay, let's see if that fixes it. Okay, that worked, and you can see that reduced our memory footprint to 802 bytes, where before we were at, let's see, what were we at before? So that saved us 30 bytes here, and so let's see if we can now run our game. Okay, so now I'm able to successfully run my game on the little display here without it crashing. And so what that means is we've saved ourselves enough memory, but we still need to have other objects and things like that that we're going to be using for, like we need to like have little like weapons and stuff that like little bolts that the spaceship moves. And so from here, if we want to move forward, we're going to have to find a way to prevent our running into this issue. And so if we take a look at our code here, this is taking up the most space, our alien fleet. And so we probably need to optimize this, and instead of creating this as a game object, an array of game objects, we probably need to make the alien fleet as a game object itself. And so what we'll do is we're going to make a class called alien fleet, and we'll use that to kind of manage this as to basically use less memory here. Okay, so we are going to, I think the way I'm going to handle this is we're going to make another class, and we'll call this alien fleet. And I was thinking about inheriting from our game object class, but I don't think we're going to. And so what we're going to do is we're going to make it a separate class, and we're just going to track the position of one alien. And so we don't have to use memory for all the other ones. Okay, and so we're going to say class alien fleet. Okay, and then we're going to kind of do some similarities with our game object class. So we should have basically, maybe we will inherit. Okay, so since there's a lot of similarities between our alien fleet and this game object class, I was going to copy some of this over, but instead what we're going to do is we're going to inherit, and like this. So we're going to say public game object, and what this does is basically it's going to make a new class called the alien fleet that has all the properties of game objects. So we do have to include our game object here, okay, to allow us to do that. And then we do need to make a constructor, so alien fleet, and then let's grab our game object constructor. Okay, so here's our constructor. And what we're going to do is we're going to pass all those arguments into our game object constructor. Position, graphic, width, height, and display. Okay, so we're going to send all those guys in there, and that's going to initialize it. Oh, no semicolon there. Okay, and so there's our alien fleet. We need a semicolon right here. Okay, and so what we're going to do is we're going to need to override some of the functions. So for example, the draw function. And so the goal here is this. In our main function, we create our alien fleet. And this takes up a lot of memory because for each member of this alien fleet, we have to have all of these things in memory. And so 2 bytes, 2 bytes, probably 2 bytes, 1 byte, 1 byte. I'm not sure how many bytes that is. Maybe 2 bytes as well. And then 1 byte and 1 byte. And so we have all of this that's taking up the memory. We multiply that by our number of aliens, so 20 aliens here, and we're chewing up a lot of space there. Okay, and so what we can do with the alien fleet is, if we just have a single game object, then we don't use up as much of that space. And so the goal here will be to basically, when we draw the aliens, just to draw it relative to the first one. Okay, so I'm pasting in our draw function from the game object class. And what we're going to do is we're going to override this. Okay, and what that's going to do is it's going to basically replace the one that's in the game object class. Good with override. Okay, so we're having some issues here. The first thing is this. If we come back to our game object class, we can't access this because this has been made private. And so we have to come up here. And we're going to add it to a different section called protected. And this will allow us to grab it in our base class there, or when we inherit from this class. That solves that problem. You know what? what we're going to have to do is this. We have to make them all be protected. There we go. And that should solve those. Now we still have this error. Okay, and so the last little thing we're going to fix here is in our game object class, we need to declare this as virtual so that we can override it. Okay, and I'm running out of time here today, so we're going to stop that and we'll continue tomorrow with implementing our new alien fleet.